Thank you for introduction. My name is Koichi Sasada from Cookpad. Today's presentation is named Guild Prototype. So 2 years ago, I talked about this. I talked about this presentation at RubyKaigi 2016. My company is different one, but I proposed a new concurrency model for Ruby 3. So it's only the proposal of idea, and the idea is, the name is Guild. So today, I show you the 進捗, the progress of this project. So the summary of this presentation is here. So we can run parallel program with Guild just now on my laptop or on my environment, but it is very buggy because it is thread program. So this means that the thread programming is too hard for me, at least for me, and maybe for you. So the keyword is thread programming is too hard. So today's talk is, I show these topics. So at first I want to introduce the background of Guild and demonstration of this kind of implementation. This is my introduction. So just now I'm working on the Cookpad, and my current job is not changed, but continue to develop the MRI implementation. Mainly, I develop the core parts like virtual machines, thread management, or garbage collection. Recently, Ruby 2.6, we released Ruby 2.6 preview 2 just before 1 hour ago. The preview 2 has such a protocol improvement for the 1.4 times faster, or passing block call where the block is passed is maybe 2.6 times faster. So it is free. So you can try just now. 5000兆円はいらない。And I'm a Cookpad employee, so I need to show this presentation page, this page. So please go to please go to our booth, Cookpad booth, at the sponsor booth room. And today we have a global office hours, and tomorrow we have a Q&A session with Kat and live coding with Endo-san and me. And don't miss the party tonight. So if you want to go to the party place with us, so please go to Cookpad booth at 1840. Okay, so let's show you the background of Guild. So the most important thing for the Ruby programmer is productivity. So I think most important thing, so we have many tasks. We have so just now we have many tasks by your by company, or you need to play Splatoon 2 or something like that. So very busy. So you need to make more program more. So making program easy. So difficulty of reducing difficulty of making program is very important. However, thread programming is very difficult. So maybe Ruby thread is very easy to use. You only need to write a thread.new with block. So you can make a block. You can make a new thread, but we cannot write a correct or safe concurrent program with thread primitives, because we need to care about synchronization or something difficult problem with because of thread programs. However, we need to utilize more and more CPUs. So just now we have, so this laptop has 4 virtual CPUs, and at your server, maybe you have 14 or 18, 80 or more and more virtual CPUs. So we need to utilize such a core, so we need to write a parallel program. However, current threads cannot run in parallel because of the thread safety or something. So the implementation difficulties or the design design choice. So to overcome such issues, I introduced guild concept. So the key idea is do not share mutable objects between guilds. So normal thread programs, we can share the objects very easily, but it introduces some database or race condition or something like that problems. So we need to introduce such a isolation to the Ruby 3. So the concept of guild is aimed to solve this problem. So the goal of the project is replace the thread to the guild. So my T-shirt says kill threads, so it means this goal. So this is the same as presentation as 2016. So guild has multiple threads, and we can make multiple guilds, and the thread belong to different guilds can run in parallel. So we only need to make guilds instead of threads, and can run in parallel. We introduce a non-shareable object. So most of objects belong to only one guild. So if we want to touch to the object belong to other guilds from the other guilds, then it causes error. So guild cannot on guild we cannot make such a programs. So such case guild is not guild prohibit this case. So at first I want to demonstrate the current implementation. I want to use this machine. So this machine has 2 CPUs, and one CPU has 10 cores, and each core can employ the 2 hyperthreading. So there are total 40 virtual CPUs, like that. So we can see the top command, and the utilization is so low. You can see. So at first, I want to show the very, very simple parallel programs. So calculate fib with 23 23rd Fibonacci number and 100 kilo times. So so without guild is very easy. So repeat this calculation. With guild version, I make this kind of architecture. So this is a manager guild, and this guild manages idle guild. So this main guild sends a task. So sends a number n, and fib half guild checks the idle worker guild, and if it can find the idle guild, then send a task the number of n. and then Fibonacci worker calculates the number of, so given number of Fibonacci number. And we can change the number of workers. So this is a program, but so usually we only need to write this kind of 3 lines. So such long lines are the code for the people have guilt, and maybe such a long code can be close to the framework. So this is the speed up ratio compared with the serial execution. So if we increase the number of guilds, then the performance is very grow and grow. And so as here, maybe 16 times faster than the serial execution, we can see for the Fibonacci number 23. And so this figure changes the number of guilds. So this next try is we fix the number of guilds. So it means we use 40 parallels, 40 workers, and change the n. So fib 0 to the fib 13. This is a figure. So Fibonacci number of small number is very low, and the task is very, very small. So we can not see the difference, but such a huge task, so we can see the huge improvement with this kind of parallel execution. So with 40 guilds, we can finish in 30 minutes. But using only 1 guild or normal Ruby scripts, then it consumes 3.5 hours. I need to run these trial in a day. So this is compare with, so how much faster than the speed up ratio of compare with serial execution with parallel execution. So only with small tasks, small number of Fibonacci, so only a few tasks, the task of weight is very, very low. So we cannot see the speed up. But maybe about this point, it is equal. So it means that using 40 cores and only using the one core, it is the same performance. But if we employ more and more guilds, we can see the speed up. So just now we have using the guilds, it introduces some overhead to manage guilds. So this is what the current implementation do. Maybe just now the current implementation is not optimized, so we can move this point to the more and more small for more lighter tasks. Another example is the word count examples. So maybe it is very easy to understand. So reading the file and split with words, and not a word count, but words, unique number of words. So this is a bit different with normal word count demonstration, but I want to introduce more tasks with this unique method. So I tried this word count for the Ruby trunks test files about the 1,000 files. And with Guild, I make a similar architecture with Fibonacci hub. So the result is not so impressive, or impressive for the with negative impact. So higher is bad. So it means serial execution is best. So with 40 guilds, it consumes 6 seconds, and serial execution only consumes 1.7 seconds. So it means because just now the current implementation introduced more very efficient global locking for the garbage collection or object management. So maybe this is why such a there are no performance improvements. Okay, so it means we have the implementation limitation just now. Okay, so I want to show the specification of Guild. This is not a fixed one, but a temporary one. So we need to discuss to improve the specification. So this is a same figure I showed. One process, one batch machine has at least one guild, and guild has at least one thread, and thread has fiber, at least one fiber. So this is a structure, hierarchical structure, and we can make multiple guilds, and threads belong to the one different guild can run in parallel. So we have giant virtual machine lock or giant interpreter lock. So we only can run one thread when the threads belong to same guild, like T1, T2. So if you want to run in parallel, then you need to make many guilds. The current construction code for the guild is here. So so this is very similar to the thread. So we only need to change the keyword thread to the guild, and you can make a new guild. But the expression 1 and expression 2 can run in parallel. And the key concept of guild is share only shareable objects. So we define the two kind of objects: normal mutable object or shareable object. So we can, if the objects are shareable, we can share the guild between different guilds. But the guild normal mutable object, non-shareable object is not prohibited, is not allowed to share between multiple guilds. So the key concept of design of shareable object and non-shareable object. So to keep compatibility, so you can enjoy usual mutating programming. So maybe if you make a Ruby program, you always mutating objects or something like that. So, but if you want to introduce threads, then you need to consider which is the shared object or which is not shared object. And if it is a shared object, then we need to synchronize with such a shared object. But so with Guild, you don't need to care about thread-sec concerns because we can't share mutable objects. So in other words, so this is the point. So you can't make thread unsafe program with Guild. So thread safe has several meaning, but this only says that data lazy program you can't write. you need to use shareable object to share the object between guilds. But so if you have experience with using making a concurrent program, maybe you can understand that there are many local objects. So local objects are not shared with between threads, but only a few sharing objects. So many non-shareable objects and only a few shareable objects are there. So you need to concentrate to such a shareable objects. So I want to introduce shareable object and non-shareable objects. So non-shareable object is normal mutable objects. So most of string or array or something, so usually we use the objects we usually use is non-shareable objects. So they are member of only one guild. So such objects they belong to guild 1, and they belong to guild 2, and guild 2 cannot touch to the object. This object belongs to the guild 1. So it means that if you use only one guild, then it is completely compatible with Ruby 2. And we introduced the shareable object concept. So we have several kinds of shareable objects: immutable object, class module object, and special mutable object, and isolated block. This page is same as the same page as RubyKaigi 2016, so it is not new feature. So we can share immutable object because we don't need to care about the mutation. And some of our objects are already immutable, so we can exchange such immutable objects. And class and module objects are also shareable objects. So there are many discussions with this design, but I have no time to discuss details. So I only show the key points. So there are advantage and disadvantage to share the class and module objects. So most of objects, immutable object or something like that, most of all of shareable objects point to the class or module because they belong to any one class. So if we need to separate the class or module object between guilds, so it is difficult to exchange such immutable objects. So it is easy. So the program is very sharing class or module objects makes program easier, but the class or module object is mutable, so we need to care about that. So for example, the class C can point to the mutable array with constant. So we cannot share such a mutable object between guilds. But if we can share the class C, so we can lead to this mutable object from different guilds. So we need to prohibit such a case, such a situation. So we will introduce a special protocol to prohibit such a case. And the number 3, special mutable objects. So if we mutable objects, if we prohibit all of mutable objects, sharing mutable objects, it is very difficult to make a program. So we need to introduce some kind of such a shareable special object. So special object require to use special transaction or special synchronization explicitly, so we don't need to care about the synchronization. Maybe so compare with normal array or hash or something, normal mutual objects. So we need to require a special synchronization protocol, and we need to introduce overheads for such things. But maybe we need, so it is same as a thread program. So we need same cost to the cost for synchronization. Maybe this is a new one, new specification. So normal proc can point to the mutable objects. So this proc refers to this outer variable, and the outer variable is point to the mutable object, mutable array. So we cannot share such a proc. So we introduce isolate proc, maybe made by proc isolate, which prohibits to access outer variable. So for example, this program, so isolated program, it should be a runtime error at some time. So I introduced this slide, but this block is isolated one. So if we refer to the outer variable, so in this case, guild 2 try to refer to the G1, the outer local variable, then it should be a runtime error because block is isolated. And the model of inter-guild communication is ACTA model, like ARM or something like that. So destination address are represented by guild itself, like Elixir or ARM processes, and sending shareable object means sending only reference. So we can send a reference only for the shareable objects. So I listed before. And if we want to send a mutable object, then we have two types of methods, copy and move. And this is a very simple send and receive method. So like that. So making guild 1, and guild 1 try to receive the object from others, and receive the number of n and calculate Fibonacci number, and send the result to the parent guild. And the parent guild send to the number 13, and this guild receive perimeter try to receive the object, and the result would be this number. So we only need to send a reference to the with this shift operator. And also, if we send a mutable object O1, then we copy everything. We copy everything. Everything means O1 refer to O2 and O3. Then we need to copy everything, O1, O2, and O3, and then receive the copied object at guild 2. But if we use a move operation, then we only need to copy the header of object, so it will be lighter than the full copy. So maybe so if we don't access to send objects after sending them, then we can send them faster. So for example, if we huge long strings data, then we can use move or IO. If you want to send IO objects, then the move operation would be nice to use. So this is a long summary. But the most important thing is mutable objects are not shared accidentally as thread programming. So it achieves the correct concurrent programs. The implementation of guilds is, just now it is very buggy, but I want to show some part of implementation. So before introducing the guild, so the virtual machine has multiple threads and thread has multiple fibers. But if we introduce a guild, so virtual machine need to maintain multiple guilds and the same hierarchy structures. So to do that, we introduce RB guild T, new data structure. And we need to many synchronization. So multiple threads cannot run simultaneously when we don't have guild. But after we introduce a guild, some threads can run in parallel. So we need to synchronize such a thread. So so just now I only introduced some part of synchronization as not completed. So this is why it is a bit buggy. So it is multi-thread programming. So it is very difficult. So I'm not sure I can complete such things, but I want to try. And garbage collection. So the garbage collection is very big, very big concern because we need to synchronize such the virtual machine global resource. So object heap, so marking or managing such a VM global heap is a very big concern. So we need to stop all of threads by sending a pause request. And after all of threads stop, then run the GC process. And after GC process, so more exact, after the marking process, then send a restart request, and restart continue the normal processes. To make this algorithm, so I think I only need a few days, but I consume 2 weeks to implement it. But it is not completed because it has sometimes it causes some critical errors. So it is so the thread programming is very difficult. I need to work more and more. So to satisfy the features, we need to prohibit sharing non-shareable objects and to introduce synchronization to protect virtual machine-wide resources such as process global resources, and also introduce the shareable object protocols. So I show the specification, but I didn't satisfy such features just now. And to improve the performance, we need to reduce the synchronization. So inserting the many synchronization, it makes program safer and safer, but the synchronization can reduce performance. Synchronization is purely overhead, so we need to introduce some better algorithm to manage such things. And the other thing is more advanced optimizations. Honestly speaking, 10 years ago, I made it with the thread program. And so I make parallel threads for the Yelp 10 years ago. So I invented some techniques to optimize such a synchronization. So I want to introduce same techniques to the guild. So before this presentation, I think it is easy to introduce such a optimization techniques because I made it. But after 10 years ago, the interpreter was very different from the 10 years ago. The implementation, so because garbage collection is generational and virtual machine has more and more optimizations, so I need to try introduce such optimizations. And one more, I want to introduce about the naming of guild. So the name of guild is maybe I think the most important is the prefix. So the T, F is used by the process thread fiber. So I want to introduce different letters to show the different show the guild. And ownership can be explained with word membership. So if we want to, so ownership is used by other languages, but membership is also good abstraction, I think. So this is why because of membership, I choose a guild. And it is easy to explain the move semantics, I think. But move operation is not so popular for the concurrent programs nowadays, and no other languages use this terminology. So repeating that naming is very important. So we are discussing about what is a good name. So I like guild, but it can be changed in the future. So just now, the guild is only a code name of this project. So today, I show these topics. So thank you so much.
Thank you, Koichi. I guess you may have so many questions in your mind, but please feel free to ask him personally during this conference. So, by the way, I love your T-shirt. Can I show your back as well, Senaka, for the Japanese audience? Senaka misete. Lovely. So thank you very much, Koichi.